Hello, so in today's class we will look into the next application of the generalized principle of inclusion and exclusion. So it is used to find out the number of surjective mappings and this will in turn give you another expression for Starling's number of second kind. Okay, now let us look into what is the number of surjective or onto mappings from a set of n elements to m elements. So when you take S of nm, S of nm is the number of ways of distributing n objects to m identical box such that no box is empty. So S of nm denotes, so that's the Stirling's number of second kind. So this is the number of ways of distributing n objects to m identical boxes such that no box is empty. Now let us look at the number of surjective mappings from surjective or onto mappings from n to n, where n comma m belongs to n. So the number of surjective mappings from nn to nm. Okay. For surjective mapping അല്ലെങ്കിൽ onto mapping എടുക്കുമ്പോൾ every element in nm must have a pre-image in nn. So it is like the number of ways of distributing n objects into m boxes such that there is no box which is empty. അപ്പോൾ ഇനി the difference here is നമ്മൾ S of nm എഴുതുമ്പോൾ the m boxes are identical, but here the m boxes are distinct. So therefore the number of surjective mappings will be, now since the boxes are distinct here, so they can be arranged among themselves in n factorial ways. So that is n factorial into S of n m. So it is like the number of ways of distributing n objects into n m different boxes such that no box is empty. So the number of surjective mappings is given by n factorial into S of n m. And now we will find an expression for the number of surjective mappings using the generalized principle of inclusion and exclusion. We will find in a different way another expression for the number of surjective mappings. So that will give us an expression for S of nm also. Okay. So let us move on to that. Let us state it as a theorem. So let f of nm, where n and m belongs to n, denote the number of surjective mappings from nn to nm. Then f of nm is given by summation k equal to 0 to m minus 1 all raised to k mck m minus k all raised to n. So this is the expression for f of nm, so which is the number of surjective mappings. So here f of nm can be regarded as the number of ways of distributing n distinct objects into m distinct boxes so that no box is empty. ആണ് നമ്മൾ ആദ്യം പറഞ്ഞ expression for the number of surjective mappings. So the number of surjective mapping is same as the number of ways of distributing n objects into m distinct boxes so that no box is empty. So that number of ways is denoted by f of n m. So we can find out a connection between s of nm and f of n m. So let us look into the proof. Now, for applying the generalized principle of inclusion and exclusion, so we need to have a universal set and we need to have certain properties. Okay, so let us define the universal set and the properties. So let S, the universal set, be the set of all the mappings from Nm to Nm. So let S be the set of mappings from Nn to Nm, and we define, so we will define M properties Pi where I equal to 1 to etc. M for each members of S as follows. So for each I equal to 1 to etc. M, a mapping, so an element in S will be the mapping. S എന്ന് പറയുന്ന set of all mappings ആണ്. അപ്പോൾ ഓരോ mapping ആണ് നമ്മൾ ഓരോ property satisfy ചെയ്യുന്നുണ്ടോ നോക്കും. So for each I equal to 1 to M, so a mapping F from Nn to Nm is said to possess property Pi if and only if I does not belong to f of Nn. That is, so a mapping F is said to satisfy property Pi if and only if I does not belong to f of Nn. So I does not belong to the image set. So the element I of Nm is not contained in the image of Nn under the mapping F. So under the mapping of F, I will not be contained in the image set. So the property Pi means I must not be contained in the image set. അപ്പോൾ നമുക്ക് surjective mappings വരണമെങ്കിൽ all the I must be contained in. അപ്പോൾ 1, 2, 3 etc. M. That is say Nm ൽ നമുക്ക് m elements ഉണ്ടാവും. അപ്പോൾ all the m elements must be contained in the image set. അപ്പോൾ നമ്മുടെ properties പറയുന്നത് ഇതാണ്. Satisfies the property Pi if I does not belong to the image set. So satisfies the property Pj if J does not belong to the image set. So the number of surjective mappings will be the number of elements in S which possesses none of the properties. Okay, so we must have every element belonging to the image set, but it must possess none of the properties. So namakku E of 0 aanu kandupidikkam. Okay, so therefore a mapping F from Nn to Nm is surjective if and only if F possesses none of the properties Pi, where I equal to 1, 2, etc. M. So therefore F of Nm, that is the required number of surjective mappings, so that will be equal to E of 0, so which is omega of 0 minus omega of 1 plus omega of 2 minus omega of 3 plus etc. Minus 1 whole raised to m omega of m, where we are having m properties. Now let us find out the values of omega of 0, omega of 1 up to omega of m. Omega of 0 by definition, that is cardinality of S. For omega of 0 nu parayunnathu it possesses okay, that will be cardinality of S. അപ്പോൾ cardinality of S എന്ന് പറയുന്ന S is the number of S is a set of all mappings from N to Nm. So S is a set of all mappings from Nn to Nm. അപ്പോൾ ഇവിടെ in the set you have n elements and here you have say m elements. So 1 can be mapped to all the m elements. So you are having the elements 1, so 1, 2, etc. n. Now for 1 there will be, we need to find the set of all the possible functions. So for 1 there will be total of m choices. അതുപോലെ 2 m choices under, 3 is having m choices, അതുപോലെ n is having m choices. So the number of such mappings will be given by m raised to n. So cardinality of S will be equal to the number of all the mappings from Nn to Nm, so which is equal to m raised to n. Omega of 1 എന്ന് പറയുന്നത് that will be summation over I equal to 1 to m omega of Pi. Let us find one of the omega of Pi. Okay, അപ്പോൾ omega of Pi എടുക്കുമ്പോൾ നമ്മുടെ സെറ്റിൽ okay, the domain has n elements and in the range it must not be mapped to I. I യിലേക്ക് മാപ്പ് ചെയ്യാൻ പറ്റില്ല. ഓക്കെ, അപ്പം നമുക്ക് ബാക്കി എത്ര വരും? ഇവിടെ m-1 elements വരും. അപ്പോൾ 1 have m-1 choices, അതുപോലെ 2-ന് m-1 choices ഉണ്ട്, n-നും m-1 choices ഉണ്ട്. So we will get m-1 raised to n. So each omega of Pi will be m-1 raised to n, and total we have m of them in number. So number of properties എന്ന് പറയുന്നത്, we are taking one property at a time, so we will get mc1 times m-1 whole raised to n. And similarly omega of 2 will be summation omega of Pi Pj where I less than j. But it must not be mapped to 2 elements. അപ്പോൾ ഓരോ എൻട്രി എടുക്കുമ്പോഴും അതിന് നമുക്ക് m-2 choices ഉണ്ട്. and the number of properties taken at a time is MC2. So we'll have MC2 into m minus